Good morning, students. In the previous session, you have learnt about the definition of a complement of a set. So, when a universal set U is given, if A is a subset of the universal set A, then universal set U, then A dash is called as a complement of the set A, and it contains all the elements of U which are not present in A, which do not belong to A. And I have given you some laws. They are called as a De Morgan's law, the law of the empty set, law of the universal set, double complementation, etc. Now, using them, here one thing they may ask you, prove the De Morgan's law. So, you should know what is the statement of the De Morgan's law. If the law is given directly, if they ask you to prove that one, it's well and good. Sometimes they ask you, prove the De Morgan's law, giving the data here, they ask you to prove the De Morgan's law. Then you should know what do you mean by the De Morgan's law also. Usually they ask you prove that one. So, sometimes for a 1 mark question, a universal set would be given, you will be asked to find the complement of a certain set. Now, we are going to work out some problems in which we make use of the properties, the definition, the knowledge of all those things. Now, first problem. Now, let U be equal to, the universal set U be equal to, containing the elements 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, set A contains the elements 1, 2, 3, 4. Set B contains the elements 2, 4, 6, 8. Set C contains the elements 3, 4, 5, 6. Now, you have to calculate some sets here. One by one I am giving. The first one, find A dash. So, A is given here, you have to find A dash. What do you mean by A dash? You have to get the elements of the set U which are not present in the set A. See 1, 2, 3, 4, they are present here. But for that, what are the elements here? 5, 6, 7, 8, 9. So, write it as it is 5, 6, 7, 8, 9. So, these are the elements which are present in A dash. Next is B dash, second one, find B dash. It can be expected for a 1 mark question. So, what are all the elements that are present in U but not in B? Now, 2, 4, 6, 8. So, 1 you can take here, 1, 2 is there, don't take, then 3 you can take, 4 is there, omit that one, then 5, 6 you don't take, then it is 7, 8, 9. So, it is having the elements 1, 3, 5, 8, 9. Now, if C dash is asked, no, 3, 4, 5, 6, you can write 1, 2, then 7, 8, 9, like that you can write. Next is, I am combining two sets, then you have to get the complement of that one. Next is, suppose you take A union C whole dash. If it is given, even 1 mark question, such things can also be, such type of problems can be expected. A union C whole dash. Now here, A means 1, 2, 3, 4. C means 3, 4, 5, 6. First let me write the union. 1, 2, 3, 4. 3, 4 is common. 3, 4, they are common elements. 1, 2, 3, 4, 5, 6. Right here, dash. I have taken the union, then written the dash there. That means you have to take those elements of U which are not here. 1, 2, 3, 4, 5, 6. So, all these elements are omitted. What would be remaining? It is 7, 8, 9. So, A union C whole dash will be containing the elements 7, 8 and 9. Similarly, you take the other combination, say A union B whole dash, that is A is 1, 2, 3, 4 and B is 2, 4, 6, 8, it is containing. So, what is the union here? Let me write the union 1, 2, 3, 4, write all the elements of A. Here 2 and 4 are repeated, write the remaining 2 elements. It is 1, 2, 3, 4, 6, 8. carefully write dash. That means you have to take the complement of this set, go to the original, that is the universal. 1, 2, 3, 4, 6 and 8. What are omitted? 5, 7 and 9. So the complement of this would be containing 5, 7, 9. These are the elements. Now another thing I told you, the double complementation I mentioned in the previous one, that is complement of the same thing, complement of the complement, we are getting back the original. Look at this one, A dash is already there. Suppose you take the complement of this one, 5, 6, 7, 8, 9. Then omitting these elements, now what would be remaining there? It is 1, 2, 3, 4. A dash is already there. I am taking the complement. It is 1, 2, 3, 4. What is 1, 2, 3, 4? It is nothing but A only. So they may ask you like this, show that A dash dash equal to A. Or they may ask you here, of course you could have used the De Morgan's law also to prove that one. But here they have asked you only to find the complement of A union C, complement of A union B. And one more thing, the next one is B minus C whole dash. What do you mean by B minus C? The elements should be present only in B but not in C. That is, say B minus C the whole dash. So I have defined the difference here. B minus C means the elements which are present only in B but not in C. Now B is having the elements 2, 4, 6, 8 and C is having the element 3, 4, 5, 6. Now when you take the difference, the common elements have to be omitted, 4 and 6 and 4 and 6. If you take out that one, what are the remaining elements? It is only 2 and 8. So we are having, it is 2, 8, the dash of this one. So first I write B minus A, take the complement. So go to the original set, the universal. Omitting 2 and 8, what are all the remaining elements? 1, 3, 4, 5, 6, 7 and 9. Write that one. It is 1, 3, 4, 5, 6, 7 and 9. So leaving these two elements, now we have to write the remaining elements. So that is called as the complement of B minus C. So whatever combination may be given, the same procedure, but see whether it is union or intersection or difference. So you have to go through the problem correctly and taking the data correctly from the given problem, you have to get the result. You have to get the problem solved depending upon whatever has been asked in the problem. Now let me move on to another problem. Here I am considering the alphabets as the universal set. It is A, B, C, D, E, F, G, H. So I am taking the first 8 alphabets of the English literature. Now you have to find the complements of the following sets. The sets I have given you. Set A contains A, B, C. Set B contains D, E, F, G, H. And set C contains A, C, E, G. A, C, E, G. And set D contains F, G, H, E. Now these are the 4 sets I am considering. You are asked to find the complement of these 4 sets, complement of all the sets here. One by one let me consider. A has been given to us. So let me write A dash. First one is A dash. See, A, B, C we have taken. What are the remaining? D, E, F, G, H. Just omit those elements. Write the remaining elements. It's easy to write the complement here because the universal set would be there. Just to neglect those elements which are present in a particular set, take the remaining elements. So it is D, E, F, G, H. Take the set B here. B dash. B dash means, see D, E, F, G, H. Then what are the remaining elements? It is A, B, C. Correct? Look here. A was having A, B, C. Now it is B dash. So they are actually mutually the complements. They are complement of each other or mutual complements, I can say. Now take the set C. A, C, E, G. Now C dash would be equal to A, omit that one, write B, C, don't write that one, then write D, E is there, then write F, G is there, then write H. So it is B, D, F and H. Lastly, take D dash. D dash means F, G, H, A. Now, leaving out these elements, A is there, you can write B, then C, then D, then E. Okay, then F, G, H, they are already present. Therefore, D contains B, C, D, E. So, these are usually asked for a 1 mark question. The universal set would be given and you will be asked to find the the complement of that one. Maybe one set may be given or more than one set may be given. If you are asked to prove the De Morgan's law, in that case, the sets, 2 sets would be minimum given, then only you can get the result here. Now, I am considering N to be the universal set. N to be the universal set. Now, what does N stand for? It is the set of the natural numbers 1, 2, 3, 4, 5, 6, 7, 8, etc., etc. Okay. Now, N is the universal set for the problems which I am going to work out now. Now, for each one, you have to consider the complement of that one. One by one, I am writing. So, the universal set is N. First one, I am giving the set in the set builder form. That means that it is given in the sentence. Now, A contains all x such that x is an even natural number. Even natural number. When it is given in the set builder form, you better write in the same form. See, what is the universal set? N. Even natural number means 2, 4, 6, 8, 10, 12, etc., etc. So, what is the complement of this one? All odd numbers. So, you need not write in the roster form. You write the answer, x is an odd natural number. X is an odd natural number. Okay. If you write this one, there is no need to write the numbers here. In some problems where it is necessary, you write the number. Otherwise, it is an even natural number, the complement would be an odd natural number. Now, take the next one. Say, set B. It contains all x such that x is a positive multiple of 3. Positive multiple of 3. What do you mean by multiple of 3? The numbers which come in the table of 3. 3, 6, 9, 12, 15, 18, like that. Okay. Don't write the number. Now, B dash. So, if you omit those numbers from the set, universal set N, what is remaining? 1 and 2, then 4 and 5, then 7 and 8, like that. There is no need to write all the elements. You write in the set builder form only. You write x is not a multiple of 3. X is not a multiple of 3. It was x is a positive multiple of 3. You just write x is a not multiple of 3. Of course, you can write here x belongs to n. That is there, because of course the universal set is n only. So, you have to write x is not a multiple of 3 and x belongs to n here. That is the set of the natural numbers. Now, like this, when it is given in the form, the set builder form, better you express that in the set builder form only. Now, the next is, here carefully you write, the set C contains all x such that x is a prime number. X is a prime number. Little bit careful you have to be in this problem. X, it contains all x. Look here, the prime number we have, the 2 is the first prime number. 2, 3, 5, 7 like that we write, isn't it? So 2 is the only one even prime number. All the remaining prime numbers are odd. But 1, it is neither a prime number nor a composite number. We define the prime number, a number greater than 1 we write. Therefore, 1 is neither a prime number nor a composite number. So here, all the remaining numbers are prime numbers. We are considering a set C containing only the prime numbers. So it starts with the 2. So complement means x would be equal to 1. 1 would be there because it is neither prime nor composite. Now x is equal to 1 and then you write x is a composite number. X is a composite number. Okay, we need to write the actual elements because it is not in a sequence here. It is not in a particular order. X is equal to 1 because the prime number start with 2. 1 is there, and any other number which is a composite number which is not a prime number. So this is how you have to write. Next, set D is containing all x such that x is a natural number divisible by x is belonging to n, divisible by 3 and 5. A number, it is a natural number which can be divided by 3 and 5. By both the numbers it has to be divided. So it can be 15, 30 like that because 15, 30, 45, no, those numbers are divisible by both 3 as well as 5. So what can be the complement of that one? It contains all x such that x belongs to n. That is a natural number we have to write x belongs to n. X is divisible by 3 and 5. How do you write the complement? X is not divisible. X is not divisible by 3 and not divisible by 5. This is how you have to write. Write in the sentence only. Divisible by 3 and 5 means it has to be, it can be divided by only 3, both 3 and 5. Now, you have the complement would be the remaining numbers. See, starting with 1, it is 1, 2 like that. There is no need to write all those numbers. Write the condition. X is not divisible by 5, x is not divisible by 3. Now, set say E. It contains all x such that x is a perfect square. X is a perfect square. Of course, I will consider only the natural numbers. What are the perfect square? 1 square is 1, 2 square 4, 3 square 9. So 1, 4, 9, 16, 25, 36, 49 like that. Now, you need not write all the elements and write the complement here. It is, you simply write x is not a perfect square. X is a perfect square is the set. X is not a perfect square is the complement of that one. Now, these problems having the same universal set n, I had given them in the set builder form. Suppose it is given using a particular condition. Set builder form only, some condition would be given, you have to write the answer. Take it on the next set. Here, f contains all x such that 2x plus 5 equal to 9. It's an equation is given. You have to consider all those values of x which satisfy the particular equation. Giving x some value, the sum should be equal to 9. So let us solve the equation. You can do that in the working column. 2x plus 5 equal to 9. That is 2x equal to 9 minus 5. That is 4. Therefore, x is equal to 2. So instead of giving that this is containing a singleton, f is containing only one element 2, it has been given like this. So how do you write the answer here? F dash would be equal to, it contains all x such that x is not equal to 2. Or you can write here itself, either you can write this one or you can write the condition 2x plus 5 is not equal to 9. That way also it can be expressed, because it's a singleton we are getting here. You write x is not equal to 2. That is the complement of the set F, which is defined in a particular way. So according to the way it has been defined, the rule that has been given, you have to use that condition and write the complement. Now let me take another set G which contains all x such that x plus 5 equal to 8. Now x plus 5 equal to 8. Here x plus 5 equal to 8 means what would be x equal to? Taking 5 to the other side, which becomes minus 5, x is equal to 3. So it is as good as writing, it is again a singleton containing 3 here. So what can be the complement of that one? It contains all x such that x is not equal to 3. This is also correct, or you can write x plus 5 not equal to 8. Both ways you get the answer for, you get the mark for that one. Either you can use the condition directly without finding the value, but better if you write the value and write the complement, that is the presentation would be better. Now take another set H. Here it contains all x such that x is greater than or equal to 7. I am considering the n to be the universal set. Greater than or equal to 7 means it would be 7, 8, 9, 10. Any number above 7 here. More than or equal to 7. Therefore, what would be H dash here? It contains all x such that x is less than 7. We cannot have the equality because already the equality is there. So x is less than 7, but here one condition you have to write, x belongs to n. X belongs to n, because less than 7 means you can go for the negative numbers also, 0, minus 1, minus 2. But since the universal set is the natural numbers, you have to write x less than 7 and x belongs to n. So what are the elements possible? 1, 2, 3, 4, 5, 6. Here it becomes a finite set. You can write the actual elements, but even if you write this much, x is less than 7 and x belongs to n, that would be enough, and you get, these are all again 1 mark question. All of them will not be asked in one problem. When the universal set is given, they may ask 1 or 2. If one set is asked, no, 1 mark, otherwise it would be 2 mark question. Now take another set J which contains all x such that x belongs to n and 2x plus 1 greater than 10. 2x plus 1 greater than 10. Again it's a simple equation, inequality actually. 2x plus 1 greater than 10 means 2x would be taking 1 to the other side. Just like equality, we can take it to the other side. 10 minus 1 becomes 9. That is, x is greater than 9 by 2. But remember, we are considering only the natural numbers. 9 by 2 is a fraction, 4.5. It's a rational number. So we have, but here strict inequality is there. X is greater than 9 by 2. 9 by 2 means it is 4.5, 4.5. So more than that means 5 is the first number. So 5, 6, 7, 8 like that. The value, the J is containing the elements 5, 6, 7, 8, 9, 10, 11 like that. Therefore, what would be J dash here? It contains all x such that x belongs to n, and then write x is strictly less than 9 by 2. They are greater than 9 by 2. We cannot write the equality here. Equality means it becomes a rational number, but we are considering only the natural number. Therefore, there also strict inequality. Here also strict inequality. X is less than 9 by 2. 9 by 2 means 4.5. Less than means 4. So it actually containing 1, 2, 3, 4. So this condition should be there. X belonging to n. Otherwise, less than 0 also we have to take into consideration. That is not possible because the universal set is nothing but the set of the natural numbers. Now one more set, say set x k containing all x such that x belongs to n and 3x plus 2 is equal to 5. 3x plus 2 equal to 5. So it's a very simple equation I have given. 3x plus 2 equal to 5 means 3x would be equal to 3, x would be equal to 1. So what can be the complement of this one? K dash would be containing all x such that x belongs to n, and then x is not equal to 1. X is not equal to 1. That means starting with one omitted. So what are the remaining elements? 2, 3, 4, 5, 6, 7, etc. Those are the elements here. So this is how sometimes for a 3-mark question, they may ask you to prove the De Morgan's law. De Morgan's law means, given it one, A union B whole dash would be equal to A dash intersection B dash, or A intersection B whole dash would be A dash union B dash. So 2 operations would be there. Left hand side union means right hand side intersection. Left hand side intersection means right hand side would be union. Sometimes it's a rare question. So if it is given, they may ask you prove the De Morgan's law, or they may ask you prove and the result may be given. In that case you carefully calculate A dash B dash and A union B whole dash or A intersection B whole dash. Then depending upon what result has been asked, you have to get the result here. Now in the coming session, I am going to work out some practical problems. Here I am going to give you some rules, some formulae. The formula are not there for proof. You just by heart those formulae. Using them, we are going to work out some statement problems. So you have to read the problem correctly, write the data correctly, then you can solve the problem. Those results which I am going to give you are the formulae. They are important. By heart them properly, and then you can solve the problem. That I take up in the coming sessions. Thank you.